Alright, so in the previous videos I showed you how to multiply monomials times monomials, monomials times polynomials, but what happens when you have a polynomial times another polynomial? So several terms times some other several terms. So in the first parenthesis, I can see that I have two terms, right, separated by plus and minus signs. There's an x and a y separated by a plus sign, so there's two terms. On the second polynomial, I have three terms as x squared, negative xy, and positive y squared. So I have three terms. At the end of this multiplication, a 2 times 3 system should give me 6 terms before I combine my terms. So let's try to keep track of how many multiplications we have done. So if we follow the area method that I've been showing you, we usually do it, we have a rectangle and we split it into whichever units I have on the second polynomial. So since I have 3 terms in the second polynomial, that's why I have 3 squares over here. But now, instead of having a monomial outside, it looks like I have 2 terms. So the area of this rectangle is going to be a little bit larger than what you think. So it's going to have 2 terms on the left, and it's going to have 3 terms on the top because I have 2 terms in the first polynomial and I have 3 terms on the second polynomial. And can you see that after the multiplications, I'm going to have the required number of areas, right? 1, 2, 3, 4, 5, 6. So we were expecting 6 areas. So make sure that your square has as many areas as you were expecting terms. So let's find the multiplications of those areas. Okay, so vertically, I'm going to place all of the terms that I have on the first polynomial vertically. So that's going to be x, or we can just say positive x and positive y. So those are the two terms that I have, positive x and positive y. Now on the top, I'm going to place the terms that I have inside the parentheses. The first one's x squared, the second one's negative xy, and the third one's going to be positive y squared. So let's find the multiplication or the area of the first square over here. So the first square, that's going to be x times x squared. So x times x squared. So you have the multiplication of two variables. You have to add those two exponents. If you add those two exponents, the first exponent is a 1. So that's going to be x to the power of 3. That's the area of the first square, x to the power of 3. Now let's see if we can find the area of the second square, which is going to be negative xy times x, right? This guy's over here. Negative xy times x. So, well, let's just say x times negative xy. Okay, so in this case, you have to multiply the signs first. So I have a positive sign and I have a negative sign. So this result is going to be negative. And then you have to multiply the x's. So I have x to the power of 1 times x to the power of 1. This is going to give me an x squared. And then I have a y by itself. So y doesn't have anything to multiply. This should be my second result. For the third result, I have also x times y squared. So I have x times y squared. On this case, since those are two letters with, or two different letters, I cannot combine them into one only letter. So all I'm going to do is put them together, write them together, keep their exponents in there, right? X, y squared, x times y squared, x, y squared. So these are the first three areas. I have to do the same thing for the bottom three areas. Okay, so for the fourth area, the top is going to be x squared, and the bottom is going to be positive y. So x squared times y. Now, you would usually start with the term, the vertical term. So this would look something like y times x squared. And the reason I'm not going to do it like this is because I want to be consistent in the alphabetical order of my letters. So if I multiply them like this, the result's going to be yx squared. And I don't know if right away you can see that yx squared and negative x squared y are like terms. So this is the only reason why I'm not going to write them like that, because visually it's not really obvious that these two are like terms. You will have to do some inspection. Okay, so what I'm going to do, I'm going to write the x's first and then the y's, right? So x squared or y times x squared. I'm going to write the x's first, x squared, y. So that's 1x squared y. Multiply the x squared times the y. Okay, and this is what I'm going to do from now on. I'm always going to keep whichever letter comes first in the alphabet goes first in the term. Okay, so for this next term, that's going to be y times, and the line on the top is going to be negative xy. Over here, negative xy times y. So we said that we're going to keep the signs first. So since that's a positive y times negative xy, that result is going to be negative. And then I'm going to place the x's. So the x's by itself, it doesn't have anything to multiply. And then I have y times y. I have to add those two exponents. So that's negative x y squared. And for the last term, let's see if I can come up with a fancy color. It's going to be y, or positive y times y squared. So y times y squared, all you have to do is add those two exponents to y cubed. So it looks like I already found all of my areas. I'm just going to write them in a straight line. So the first area, that's x cubed. The second area is negative x squared y. The third area is positive, the yellow area, positive x y squared. The fourth area, the blue area, that's positive x squared y. The fifth area, that's going to be negative x y squared. And the last area, the sixth area, is going to be positive y cubed. So at this point, can you see that I have the 6 terms that I was expecting at the beginning? Right? I was expecting 6 areas, so I have 1, 2, 3, 4, 5. I have 6 terms. Okay. Now at this point, sometimes you might be able to combine like terms to simplify this polynomial. So instead of writing a whole line with 6 terms, you should be able to combine those. So remember that combining like terms through addition or subtraction means that they have to have the same variable with the same exponent, or the same combination of variables with the same exponents. Okay, so for the first variable, x cubed, can you see that you don't have any other x cubes around? So I'm just going to leave x cubed by itself. For the second term, that's negative x squared y. And at this point, I can see I have a positive x squared y. So if I want to combine those two like terms, I have to add the coefficients. If I add the coefficients, that's a negative 1 plus 1. Those are in reality going to cancel out. If they have the same coefficient, opposite signs, that means that those two are going to cancel out. And can you see that the same is going to happen for xy squares? That's 1xy squared, and that's negative 1xy squared. They have the same coefficient, which is a 1. They have opposite signs, so they're going to cancel out. And the only leftover term that I have in here is going to be y cubed. So that's going to be my final result, x cubed plus y cubed. So this is going to be the whole area of that big rectangle over there. So let's take a look at another example, very similar example of a multiplication of polynomials. So this is going to look like 3x plus 2. This polynomial or binomial is going to be multiplying 2x squared minus 2x plus 1. So we're going to try to do that multiplication. Again, I have 2 terms on the first polynomial. I have 3 terms on the second polynomial. So this rectangle has to look like a 2 times 3 rectangle. That's 2 times 3 rectangle. Now let's go ahead and place, well, at the end, you multiply those two, you should have 6 terms before you combine like terms. So let's see what we can do. Vertically, I'm going to place the first polynomial, which is 3x plus 2, or positive 3x plus 2. And on the top of that polynomial, I'm going to place the other numbers, which is 2x squared minus 2x plus 1, and we're going to do those multiplications. Okay. So for the first area, that's going to be a multiplication of 3x times 2x squared. If I do multiplication, I have to multiply the numbers first. So 3 times 2, that's 6. And then the letters are going to add up on the exponents. Okay, so let me just rewrite it a little bit over here. So 6x to the power of, that's a 1 plus 2. So that should be x to the power of 3. So that is the first result of the first area, which is 3x times 2x. Now the second area is going to be 3x times negative 2x. So 3x times negative 2x. So first you have to multiply the numbers. So 3 times negative 2, that's negative 6. And then you multiply the x's, those are exponents of 1, so you have to add them up. Okay, so that's the second area. The third area is going to be 3x times the top, 3x times 1. So 3x times 1, you multiply the numbers first, so 3 times 1, that's 3. And the x doesn't have anything to multiply, so it carries over. So those are the first areas. Let's say we can find the second areas. I'm gonna color code this guy over here. Plus 2. So that's a 2 times 2x squared, the one on the top right, 2x squared. So this is going to look like 2 times 2x squared. Again, we're multiplying the numbers first, so 2 times 2, that's 4. And the x squared doesn't have anything to multiply with, so it carries over. For the fifth area, that's also going to be a 2 times. On the top, I have negative 2x. Over here on the top, negative 2x. So 2 times negative 2x. First, multiply the numbers, so 2 times negative 2, that's negative 4. The x doesn't have anything to multiply, so it carries over. And then the last rectangle, that's a 2 times a 1 on the top, this one. So 2 times 1, that's going to be equal to 2. So if I write all of my areas, my resulting areas, I'm going to have the result. Of course, I might be able to combine like terms here and there, okay? So let's take a look at it. The first area, that's 6x to the power of 3 minus 6x squared. The third area is positive 3x. The fourth area is positive 4x squared. The fifth area is negative 4x. And the last area is positive 2. Remember that if they don't have any signs, those you have to assume those are positives. Okay, so at this point, let's see, I have 6 terms as I was expecting. 1, 2, 3, 4, 5, 6, as I was expecting 6 terms. Okay, so let's see we can combine like terms. Let's see we have any other x cubed around, which we don't. So this is just going to carry over 6x cubed, nothing else to combine with. Let's see if I have any other x squares around. So I have a negative 6 and I have a positive 4. So I have to add those two numbers. Negative 6 plus 4, that's negative 2. And I keep the same base, which is the same variable with the same exponent, x squared. For the third term, those are simple x's. Do I have any other single x around? That's almost towards the end, right? So if I want to combine those two, I have to do 3 minus 4. 3 minus 4, that's negative 1. And I have to keep the variable the same. Okay. And then there's also a number that's by itself. So make sure you don't forget that number. So this should be my final result, 6x cubed minus 2x squared minus, I'm not going to say minus 1x, I'm going to say minus x plus 2. And this is the result that I'm expecting from this multiplication of polynomials.